7th grade, we are on lesson 4.3, proportional relationships and graphs. So just dusting off cobwebs from the last lesson, we talked about proportional relationships and we talked about unit rates, where we're breaking everything down to the 1 unit to try and figure out whether something repeated is happening in a constant way. So we're continuing that, the proportional relationship idea, but now we're also going to see that happen in a graph format. And in order for it to be proportional, what you learned in the last lesson is that it kind of had to follow a proper equation where the total cost was going to be some unknown number times another unknown. And this is going to be the input amount. So let's use an example because that doesn't make a lot of sense without an example. Let's say you went to work and you were making $10 per hour. The total amount you earn would be 10 times however many hours you worked. So if you worked 1 hour, it would be 10 times 1, $10. If you worked 2 hours, it would be 10 times 2, $20. If you worked 3 hours, it would be 10 times 3, $30. So we don't know how much total you make until we know how many hours you've worked. And when it's laid out like this is going to be constant 10 times whatever this is. It's going to increase in increments of 10 in that. So that's how you would know it would climb on a line, in a straight line in a constant way. So those are proportional relationships. I'm starting at nothing, and I started at $0 and I went up by 10 every hour I worked. And those were proportional relationships. So we learned if I could write it this way, if I could put 10 or some number here, and then it's always going to be multiplied by whatever x is, it will stay in proportion to one another. It will stay as a straight line. Something else that you'll learn today then is how does that look on a graph? Well, if I have a graph and I started at $0, if 1 hour I made $10, there's that. In 2 hours, I would have made $20. That's their meeting point there. In 3 hours, I would have made $30. That's their meeting point there. And what you'll find is that every proportional relationship will meet 2 requirements. One is it will be in a straight line. And we know that because this is happening. It's the same amount being multiplied. It's growing by the same amount per hour or per minute or per something, right? Also, the other thing we will note, if it's a proportional relationship, is it will go through origin. Remember, origin is this point right here. I don't get anything unless I work 1 hour. So if I work 0 hours, I get nothing. So to be considered a proportional relationship, if you look on a graph, you will see a straight line that goes through origin. So if I look at a graph and I see this line, is it proportional? Yes, because it's a straight line that goes through origin. How about this line? This line? Yes, because it's a straight line that goes through origin. What about, let's use a different color, this line? It is not proportional. It is a straight line, and it can be a straight line and not be proportional. That's okay. It is a straight line, check, but it does not go through origin. Oopsie. So I would call that a non-proportional. And this is the sort of stuff we get into in 8th grade. In fact, you'll see a little bit of it in this lesson, but we start talking about a lot of these sorts of things next year too. So today, proportional relationship. On a graph, it will be a straight line that goes through origin. Both of these have to be met in order to say, yes, proportional. You will also know it's proportional if it falls into this category where y equals kx. In 8th grade, they'll start calling that an m, or your slope. But it's that amount. I make $10 per hour. $10 times every hour that I work is my total amount earned. So let's get into this, have a look, and see if it all can tie together for us. So we are given the equation y equals 5x. It's supposed to represent the relationship between the number of gallons of water used and the number of minutes for most shower heads manufactured before 1994. I'm guessing that you turn the shower head on, or you turn the shower on, and most shower heads manufactured before 1994 would put out 5 gallons for every minute that you use it. So let's write that in a form that our brains can get used to. There's 5 gallons that are coming out of there for every minute. That's a lot. And this is the total amount of gallons you used for your shower. All right. For the whole shower, when we know how many minutes you were in the shower. Suddenly, I'm looking at 5 gallons for every minute going, oh, wow, that's kind of a waste of water. I should take shorter showers. Okay, so they gave us this equation, and what we have already kind of picked up on is when we have this format, we are going to have a straight line that goes through origin, or this is a proportional relationship. So explain why the relationship is proportional. It is in y equals kx format, or y equals mx format for next year. Same thing, just they used a different variable. They used k for constant of proportionality, but next year we'll talk about what that means in terms of slope, and they use m for slope. So for now, your brain will make the transition just fine. Y equals kx format means that this is going to be changing at a constant rate. 5 times 1, 5 times 2, 5 times 3. It's going to happen at a constant rate. How does the equation represent the constant of proportionality? In this case, k equals 5. It is 5 gallons per minute, which is the unit rate, by the way, right? That k talked about the unit rate. 5 gallons per minute, per 1 minute. So we're going to complete the table. In 1 minute, we know it's going to do 5 gallons of water used. If your shower is 2 minutes long, we would plug 2 in here and do 5 times 2, which is 10 gallons, a 2-minute shower. Oh my goodness, think about how long your showers have been. All right, 3 minutes, we would plug in into 5x. I'll tell you guys, I use this, I think I showed you already. I use this, y equals 5x for whatever x is. So they used 1, 2, and 3, and some unknown number, and then 10. So 5 times 1. I like to see the calculations happen. Some of my students' brains need to see that happening. Now I'm plugging in 2 for x. 5 times 2 is 10. Now I'm plugging in 3 for x, because 3 is my x here, so 5 times 3 is 30. I plugged some number in and ended up with 35. 5 times what gives me 35? Is 7, you're right. So it must have been a 7. And then 5, well, my x is 10, will give me 50. So these are all of my x coordinates, and these are all of my y coordinates. So I'm going to go ahead and fill those in. Oh, and I just noticed nobody said anything. 5 times 3 is not 30. 5 times 3 is 15. Okay, well, at least I caught that before we got too far. And then we have 10 times 5, which is 50. A rainbow of colors going on here. Okay. Then let's put our coordinates down here. When x is 1, y is 5. 1, 5. When x is 2, y was 10. When x was 3, y was 15, Miss Sanchez, not 30. When x was 7, y was 35. When x was 10, y was 50. And then we will graph it. This is 1 on the x turn, go 5 on the y. 1 on the x turn, go 5 on the y. 2 on the x turn, go 10 on the y. 2 on the x turn, go 10 on the y. 3 on the x turn, go 15 on the y. 3 on the x turn, go 15 on the y. 7 on the x turn and go 35 on the y. 7 on the x turn, go 35 on the y. Right there. And finally 10 on the x, 50 on the y right there. If I connect those dots, I get a straight line, and it goes through origin. How about that? We kind of knew that was going to be the case because it was in the right format. This is a proportional relationship. It meets the requirements of straight line And through origin, origin right there, 0, 0, yep, it meets those requirements, so it is a proportional relationship. Then they ask us more questions. If the shower head is used for 0 minutes, how many gallons of water will be used? Well, if we don't turn on that water at all, is any water being used? Nope, none. And what ordered pair represents that? If I turn it on for 0 minutes, I waste 0 water. And what is this location called? Origin. If the shower head is used for 1 minute, how many gallons of water will be used? 1 minute is 5 gallons. That was our unit rate, right? What ordered pair represents that? 1, 5. And what does the point represent? Our unit rate, or our constant of proportionality. So that's what this is kind of giving us a chance to see. They wanted to show you, look, it ended up being a straight line. It went through origin. And then Miss Sanchez already told you that. She got way ahead of the game. Whoopsie. Okay, and so the next example, example 1, has everything done for us. But let's walk through it. The table shows the relationship between the amount charged by a house cleaning company and the amount of time worked in hours. Is the relationship proportional relationship? Explain. Okay, if it's a proportional relationship, we're going to be able to tell by this. We should see a constant amount per hour without earning money before that. And on the graph, we should see 2 requirements met. And those requirements would be, does it form a straight line, and does it go through origin? Okay, well, let's look at that constant of proportionality. Remember, we can do cost over time, divide 45 divided by 1. That is our unit rate. 1 hour gives us $45. Let's do 90 divided by 2, the cost over time. 90 divided by 2, is that going to give me 45? It is. Okay, so this is following the constant of proportionality. Last check, I'm going to do 135 divided by 3 over time to find the rate. Is that rate the same? It gives me 4 and then 15. Yes, indeedy, 45. So this is going up by 45 for every 1 hour. So they are basically, what we've discovered is they are making $45 for every hour that they work. When we know how many hours they work, we will now know how much money they earned. So this can fall into this format. So right away, right there, we should be able to say, oh yes, it is proportional. But wait, there's more. Oh, by the way, 145, 145. These are our coordinates. So if we had to plot them out, we could plot them out. They did it for us. Thank you so very much. And when they plotted them out, these are the points that they got, and it makes a straight line, pachow, that goes through origin, 0, 0, pachow. That is a proportional relationship. So here we have Jared rents bowling shoes for $6, and then he pays $5 per bowling game. Is the relationship a proportional relationship? Explain. Okay, well, I don't have it graphed yet, though I can go ahead and graph it, and I'll do that in a moment. Also, I can do the division to see if it's the same between each one. 11 divided by 1 is going to be 11. 16 divided by 2, though, is 8. 21 divided by 3 is 7. So I do not have the same constant of proportionality. So at this point, I've got something else going on. And I'm going to take you through what's going on in the translation of this because, like I mentioned, with my 8th graders, we're kind of doing the same sort of thing. This is a very common scenario for what they're working on, and it relates very, very closely to what you're looking at right now. So we'll come back to that. But let's graph these points. Already we have realized I don't have a constant of proportionality really that goes with a 0 origin thing. So I'll plot it. 1 on the x, 11 on the y. 2 on the x, 16 on the y, right about there. 3 on the x, 21 on the y, right about there. 4 on the x, 26 on the y, right about there. And if I connect those dots, and look, it still made a straight line, so pachow. But my issue is it didn't go through origin. So that doesn't count. So it is not proportional is going to be the final answer, not proportional. And you could say because it doesn't go through origin or it doesn't have the same constant of proportionality. Notice though where it goes through, the y number line? Right at about 6. Right at about 6. Here's why. He rented bowling shoes for the whole time he went bowling, right? He did not have to pay for those shoes every time he bowled a game. That was a one-time fee. So he started at $6. And then after that, it was $5 per bowling game. So the cost of his bowling is going to be $5 times however many games he played. That looks familiar, right? But there was a starting cost of $6. And as soon as you have an added amount, it's going to force you off origin. So if that comes up, you have an added amount that's a one-time fee, you won't be on origin. That's called a y-intercept, and we'll get into that next year. So it's where it crosses the y number line. By the way, it's not difficult. Where it crosses the y number line. It crosses at 6 because that's the starting point. He paid his $6 and then $5 for every game he bowled. So if he bowled 3 games, that was that was $15 plus the $6 shoes he had to pay for. $5 times 3, 15 plus the $6 he had to pay for the shoes. So since it doesn't go through origin, 7th grade level, then all we need to say is it's not proportional. But I figured I may as well take this translation and show you what it looks like as we progress forward. So that's the reason we didn't have a constant of proportionality. We do have a constant happening. That's why we ended up with a straight line. But this $6 initial fee was what threw things off a little bit. Okay, and example 2, again, done for us, but let's walk through it so that we can know what's going on. We don't want to just skip it because they're trying to tell us something, right? The graph shows the relationship between time in minutes and the number of miles Damon runs. Write an equation for this relationship. Well, we know that a rate is a distance over time. So let's look at those points on the line. We have distance over time. So when he goes a distance of 1 mile, that takes him 10 minutes. So we have a 1 mile is 10 minutes. If he goes 2 miles, that takes him 20 minutes. 3 miles takes him 30 minutes. And that makes sense, right? Because if 1 is 10 minutes, then 2 would be 20 and 3 would be 30, right? So that makes sense. So what we have here is the constant is 1/10. Constant of proportionality is 1/10, 1 mile in 10 minutes. So we can write it in the equation of y equals, and our constant of proportionality is 1/10 times x. X would be however many minutes he ran. So this would tell us if he ran 30 minutes, 1/10 times 30 is going to give us 3. So we would have 3 miles run. So this is how you would get the constant. This is how you'd get the constant of proportionality, distance over time, and we want it as a unit rate, the 1 mile rate, and then there you go. We have k equals 1/10, and then we just fill it into our equation. That's it. I hope that all kind of came together, made sense to you, and with practice it should come together. But if you need extra assistance from me, I'm happy to help you.